Hi, I'm Elizabeth with Logicwalk. In our last lesson, we introduced the operating system, looked at the role of the shell, compared it to graphical interfaces, and distinguished operating systems from applications. In this lesson, we'll shift from defining what an operating system is to exploring how we can actually study one through simulation. An operating system is essentially a large set of computer instructions. And like any program in theory, we could simulate it by loading it into the Logicwalk Computer I/O simulator, the same simulator we used in the previous Architecture 2 course. But that approach quickly runs into problems because operating systems are massive, millions of instructions long. Reading and executing every single one would be the least effective way to study how they work. They also rely on millions of memory cells. Trying to track what's stored in each one while the OS is running is practically impossible. That's why in this course, we'll use the Logicwalk Operating System Simulator. Instead of simulating every instruction and memory cell, the Logicwalk OS simulator operates at a higher level, giving us a clearer view of the key concepts and behaviors that make operating systems work. Here's an example of the Logicwalk OS simulator. Unlike the CIOS, it doesn't display low-level details like instructions, memory cells, or the program counter. Instead, it provides a higher-level view with four main elements. The current folder, which shows us where we are in the file system. In this case, it's represented by a single slash, which indicates the root folder. We'll talk more about that in Chapter 2. The shell is the main visual interface in the Logicwalk OS simulator. You can see the shell inside the terminal window. The host name, which identifies the computer in the network. Here, it's called Computer A. And finally, the status. Although it isn't shown directly in the simulator, it's an important part of the Logicwalk OS simulator because it tells us what the computer is currently doing. With these elements in place, the Logicwalk OS simulator is ready. A typical interaction pattern looks like this. The user enters a command and presses enter. The computer processes the command and prints the output. Then finally, the user can enter another command. Let's try it out. First, locate shell A. Inside the inner rectangle, type the command pwd, then press the enter key. This command tells the OS simulator to print the name or the address of the current folder to the shell. After you press enter, you'll see the current folder, which was the root folder shown in the shell. Beneath that, you'll see a greater than symbol, which we'll refer to as the prompt or shell prompt. As with the I/O simulator, we can represent the state of the Logicwalk OS simulator as a map. Before the computer is interrupted, the simulator state looks like this. The host name is Computer A, the status is idle, no interrupts are occurring from the keyboard, so its value is false. The press key field is empty, and in the shell, the user input is also empty. The buffer is a copy of the shell, just like the display buffer you saw in the Computer Architecture 2 course. It always shows exactly what appears in the shell. At this point, the buffer shows the prompt. This signals that the shell is ready to accept more commands. Now imagine a user presses the letter C on the keyboard and interrupts the computer. The state of the simulator changes instantly. The host name and status remain the same. The keyboard interrupt switches to true. The press key now shows C, and the shell itself remains unchanged, at least for the moment. In the next lesson, we'll take a closer look at what happens to that press key and how the operating system processes it.